Okay, let's get into some worded questions. And this will be the last two examples before you start your exercises. So let's get into it. A 90-litre tank full of water begins to leak at a rate of 1.5 litres per hour. If V litres is the volume of water in the tank after T hours, complete the following. Write a rule for V in terms of T. Sketch the graph for 0 less than or equal to T, which is less than or equal to 60, labeling the endpoints, and use the rule to find these amounts. Okay. So these questions might look a little bit daunting at first, but let me reassure you guys that you've actually done a little bit of this prior to in your recurrence relation or your number patterns unit. Okay, so let's just break down the information and really understand what it's saying here. So I'm going to highlight the numbers first. I can see that 90 liters is going to be an important number. Okay, 90-litre tank full tank full of water begins to leak. Okay, really important this bit here. It's beginning to leak, which means that it's losing water. So it's going to go down at a rate of 1.5 liters per hour. Okay, that's some more interesting information there. So this is saying that at the start you have 90 liters, and then every hour it's leaking this much water, 1.5 liters per hour. Okay. Now, like I said, this stuff is actually information that you would have already in some ways encountered before, okay, in recursion. And the reason why I say that is because if you think about it, a tank that is full of water begins to leak, okay? So if a tank is full at the start, 90 liters is referring to how much it has in the beginning, okay? Now, if you remember back to the previous, I think, parts of this video, I did mention that the beginning or the initial value is the same as your y-intercept. Okay, when you see the initial value or the beginning, it refers to the y-intercept. So remember your rule, y equals mx plus c. C refers to the y-intercept. But it's also the same as the beginning, or when you see the word initially, or in this case, or for recursion's case, it's the same as the starting term. So how much did you have at the start? So there is your y-intercept. It's the same as these guys. Beginning, initially, starting term. That's what your y-intercept is referring to. And that's what this is. That's how much water it has at the start. Now the 1.5 liters, that information there is also important because in terms of recursion and number patterns, this refers to the common difference. So in that sense, the gradient, okay, is actually the same as the common difference. Okay, there's very a lot of similarities there with the question, but the gradient is the same as your common difference. So in this scenario here, we can see that we've got the information we now need to actually write down a formula. So this is our typical y equals mx plus c linear formula, linear graph formula. We're going to use this to create our rule. Now it does say here to create the rule in terms of V and T. V refers to the volume of the water, and T refers to the time in hours. Okay. We'll leave that for now, and we'll just actually focus on this rule. Y equals mx plus c. Okay, I can see that my rule here, kind of like even with recursion, you only need to change two numbers. You need to change the gradient and what's the y-intercept in your formula. Okay, those are the two things that you're going to change in this formula. So I already mentioned before that in my formula, okay, y equals, the gradient is this. 1.5 liters per hour. Okay, this is talking about how much it goes up or down by per hour. Okay, 1.5 liters per hour. Now, just in the context of the question, the water is leaking. That means it's going down. So the amount of water is decreasing each time. So it's every minute, it's 1.5 liters per hour, not per minute. Okay, so there's my rule so far. And then the next thing to include is your y-intercept. Okay, your y-intercept. Now, your y-intercept, remember, is the same thing as your how much you have at the start, initially, or the starting term. Okay, in this case, the tank started with 90 liters. So it has 90 liters at the start. There's your y-intercept. Okay, now the next part to this is we need to now change the formula in terms of V and T. Okay, change the formula in terms of V and T. Now, to actually understand which one is which, you just got to think about what values will go into your graph. Okay, so on your axis, X is referring to the X variable, Y is referring to the Y variable. Okay. Now, if you read the question, generally, if you read a question like this, the X variable will be the number that will change. Okay, is the number that's going to change each time. So if you think about it here, okay, or will be the amount that will change. If you think about it here, the thing that changes constantly is the per hour. So in this case, of my X and Y, the X variable is the thing that's going to change. Now, hour is referred to as time, T. So that means this T is my X variable. So if that's my X variable, the V must be my Y variable. And that makes sense because the Y variable is generally the amount that you're looking for, or the Y variable is what goes on this Y axis. In most graphs, okay, that you see, generally you'll find time or amount of something being done or whatever on the X variable, and Y could be like it could be amount of water or how much money was used. Now we haven't really touched on this before, but the X variable is referred to as the independent variable, and the Y is the dependent variable, or the response variable, but that's more so for data. But in this case, all you got to do now, okay, is change X and Y to whatever these variables are. So it says here V and T. In this case, V, okay, is the Y variable, and T is the X variable. So just change that in your formula. So your formula will now look like this: V equals negative 1.5 T plus 90. Okay, now when you think about it, this is actually a rule that kind of gives you any term that you want. Okay, so it's very similar to an nth term rule. In this case, we call it the gradient rule, or the y equals mx plus c rule. So just relating it back to your original y equals mx plus c, this is y equals, this is your gradient. Okay, x is your variable, your x variable, plus c. And c is your y-intercept. Okay. Alright, so the next part to this question is we need to sketch a graph for 0 less than or equal to t, which is less than or equal to 60. Now what this is saying is you need to sketch a graph that has this range, starting from 0, finishing at 60. Okay, so on my x variables, okay, on my x variable, on my x-axis, we need to start at 0 and finish at 60. And I can see that it also uses this t. Okay, t. So it's saying that this axis, where t is going to be, it needs to go from 0 to 60. So remember, t refers to the time in hours. Okay, or here. So that means over on this side of the graph, okay, I would start by putting in my values, starting at 0, going all the way to 60. So that's 0. Remember that, the origin is 0. So we're going to go up by 20, 40, 60. And this is time in hours. So if that's time in hours, okay, that must mean that on the y-axis, this must be your volume. And this is in liters. Which means that V is your y-axis. All right, that's what that's where your y-axis is going to be, where V is. Okay. So we need to sketch this. Now, in order to sketch this, remember with any graph, you only need to know 2 points. Okay, you only really need to know 2 points. Oh, actually, before I start, I forgot to actually need to also put some points in here. So, oops. Oh, sorry, guys. Okay, so let me put some values on this real quick before I forget. Alright, so we're going to go up by, well, let's see, let's have a look. At the y-intercept it says 90. Okay, now just thinking about the context of this question, okay, because it goes up to 90, I want to make sure that the highest point here is going to be 90 because it's going to go downwards. Okay, this question has the context of it is the water is going down, so it's decreasing each time, which means that the line is going to go downwards. Okay, so just going to put some values here for you guys. Okay, so we'll go up by tens. 20, 30, 40, 50, 60, 70, 80, and then 90. Okay, so we're going to have to put 2 points in here in order to label our graph. Okay, and also in order to label the endpoints. So the endpoints refer to where the line starts and where the line actually finishes. So what are the coordinates for where the line starts and where it finishes? Well, if I want to figure out those 2 points, okay, I'll have to actually use the numbers that are given here. 0 and 60 are my start and end point. Okay, so in order to figure out where exactly I have to put those 2 points, I have to use my formula. Remember the formula? Let's use V. So V equals negative 1.5t plus 90. So if I actually use my formula, I can actually find the 2 points. So let's find the first one. Let's use 0. So if I change t to 0, I'll be able to find my first point. All right, so let's substitute 0 into this formula. So 1.5 times 0 plus 90. I'm getting 0 from the first endpoint here. Okay, so this is my first endpoint. If I calculate that, negative 1.5 times 0 leaves it as nothing, and you're just left with 90. So therefore, the first endpoint is where v equals 90. So 0 over here, 90 is the first point. So that means this coordinate, or this first endpoint, is 0, 90. And if you think about it, that's actually your y-intercept. Okay, and remember as well, with your y-intercept, your x will be 0. Okay, the next point I have is, or the next thing I can use to figure out the next point is 60. So if I change my formula again, so v equals negative 1.5t plus 90. If I change t to 60, I'll get my next endpoint, 1.5 times 60 plus 90. Okay, put that in my calculator. Interesting how your calculator turns off, right? So negative 1.5 times 60 plus 90 will equal 0. So that means the next point equals 0. That means when the t is equal to 60, v must be 0. So if t equals 60 over here, v will be 0, which is staying on that line right there. So this other point is 60, 0. Those are my 2 endpoints from the start to the beginning, and then now I'll draw my graph. Just again, remember, make sure you use a ruler to draw your graphs, because it's actually quite tricky to draw straight lines like this. So use a ruler, please. It'll make your life a lot easier. Okay, and there's my graph. All right, and there are my endpoints. Sorry. Next part here is now we need to use our rule to figure out the volume of the water after 5 hours and the time taken to completely empty the tank. So if you think about it, this first part, this question, is actually asking kind of like for the 5th term. What is the 5th term using that rule? Okay, so if I use my rule, v equals negative 1.5t plus 90. Okay, what would happen if I change, or what's the value of v if I change t to 5 hours? So this is part 1, v equals negative 1.5 times 5 plus 90. Okay, so what's the value of v? Let's use that, change my formula. So this is now 5, and that should equal 82.5. So that means on the 5th hour, I'll have 82.5 liters left. Or you could say on the fifth term you'll have 82.5 liters left in the tank. All right, part 2, what is the time taken to completely empty the tank? Okay, part 2. Now again, I'm going to write my formula here. So negative 1.5 t plus 90. Now this question is asking how long will it take for the tank to be empty? So in terms of this equation, what is the value of t when v becomes 0? So if I rewrite that, if v was 0, okay, what is the value of t? What is this t going to be? So now the t becomes the unknown, that's 0. So you think about it, all I got to do is isolate t, make t by itself to figure out what it actually is. So I'm just going to swap my formula around because I do like having my unknowns on the left-hand side, but you don't have to do this. I just prefer to work this way. Now all I got to do is make t by itself. Okay, so if that's the case, let me just fix this. This kind of looks a bit ugly. Okay, make this t by itself. Okay, if I want to isolate the t, I'm moving two numbers here. I have to get rid of this negative 1.5 and this plus 90. Okay, let me start by moving this plus 90. You've all done this before. So if I move a plus or positive 90 here, becomes negative 90 on this side. So you're left with negative 1.5 t equals negative 90 because 0 minus 90 is negative 90. Next, I have to now move this negative 1.5. It is a times. So when I move it to the other side, it becomes divided by negative 1.5. All right, so what does that equal? T equals, let's use my calculator, negative 90, okay, divided by negative 1.5, should be 60, yeah. Equals 60. So that means it takes 60 minutes for the tank to be empty. Okay. Be empty. Cool. All right. So pretty straightforward, I think, that question. If you want to go ahead and re-watch it again in order to be able to do the questions. But I think one thing to watch out for would be this sketching the graph using these endpoints. So just remember to use these endpoints to figure out what the coordinates are going to be and where the 2 points are going to be. And you just substitute that into your formula to figure those out. Let's do one more question and then that'll be it. Here is an equation. Okay, so d equals 25t plus 30 is an equation for calculating the distance d from home that a cyclist has traveled after t hours. Like I said, with these questions, you'll find that distance is normally referred to as is generally the thing that you're trying to find. So that'll be a y variable here, and then generally your gradient is like your time, your maybe generally time. It could be other things as well, but in this case it's time. But just to recap, remember this formula is saying y equals mx plus c, and just remember what each of these variables refer to. So the gradient is 25, y-intercept is 30. Okay, and I've kind of given that already. Part A of this question is what is the gradient of the graph in this given equation? Okay, so what is the gradient of the graph given in the equation? So in this case, the gradient is 25. Okay, 25t. So in this case, we're just going to write 25 is the gradient. Okay, just fix that up. Is your gradient. Now remember what the gradient represents and what it's the same as in terms of recursion, just to help you understand what it means. The gradient, remember, is the same as the common difference. Okay. Now in this case, if it's the same as a common difference, it's going up by a certain amount. And it's going up because if you look at the gradient, it's a positive number. That's not going down. It's going up. Read the question. This is an equation calculating the distance d from the home that a cyclist has traveled after t hours. So that 25, okay, with the t is the gradient, and it refers to, okay, the distance this person travels per hour. Okay, the distance per kilometer that this person travels per hour. So the 25, the gradient, okay, represents the distance the cyclist travels per hour. Okay, travels per hour. Okay, and the next part B, 30. What could 30 represent? Now, this is an interesting thing. I think you could interpret it a little bit differently, but 30, remember, think of it as the starting term or the y-intercept. Okay, so 30, y has already started with 30. Okay, y is 30, already the starting distance, okay, from this person's home. Well, I kind of said it, but 30, okay, is the y-intercept. Okay, it's the same as the starting value. Okay, and in this context, it might actually represent the distance that this person has already traveled before they started recording how much distance or how far they actually already traveled. Okay, so you could say that this is the distance the cyclist traveled before calculating. Okay, or before, you can say before calculating his distance. Okay, so it's the distance he already traveled before he actually started using the formula, you could say. Okay, let me finish up with this last question. So if the graph D against T is drawn, what will be the intercept of the D axis? So let's just rewrite the formula here. D equals, what was it, 25T plus 30. Okay, so if I wanted to draw this into my my axis here, okay, let me actually put my values here. So this is going to be T, this will be D, and I might go up by, let's see, this is going up. So the line is actually going to go upwards. Okay, so I might actually use, let's go with, let's just go up by 2. So 2, 4, 6, and 8. Okay, and on my y-axis, okay, it starts at 30. So I might actually go and use, I'll go up by 20. So 2, 4, 6. So let's graph this. So first and foremost, I might start with actually what I want to do, maybe I'll go and figure out what are 2 points that I can use to actually graph this. And maybe I won't use my y-intercept this time. I know it starts at 30. Okay, I can say that it starts at 30 here. Okay, but let me not use that. Let me try a different example for you guys so we can actually draw this. Let's draw this graph using some different points. Okay, so maybe I'll use, what you can actually do is use any of these x values or these t values in this case, and substitute it into your formula to figure out some coordinates. All right, so again the rule is D equals 25t plus 30. Okay, I might use 2. Let's use 2. Let's change t to 2 to figure out what d is. So if t was 2, what would d be? So d equals 25 times 2 plus 30. And I can work that out. 50 plus 30 is 80. Okay, so d is 80. So that means that if I use 2 on my t, like there, d would be 80. So that next coordinate would be 280. So 2 and 80 will be here. Okay, let's use one more. Okay, let's see. I'll use 4 because I think if I use another number higher than 4, it will go beyond the graph. So in this case, if I change my formula, so it's D equals 25t plus 30. Okay, I change t to 4, so D equals 25 times 4 plus 30. D should be, what's that, 100 plus 30 is 130. Okay, D equals 130. So that means if t was 4, so if I have 4, D would be 130. That's my coordinate. Right, so if t is 4, D is 130, which is about here. And then from there, draw your line, and you could probably keep going till the end. Okay, but that's it for this exercise, for this chapter. Hopefully, I know it's a bit long, guys, but bear with it. It's pretty straightforward. Just make sure you watch the whole thing. But go ahead and start your exercises for chapter 1F. Okay, there are a few questions there to do. Okay, so questions 1F. That is your exercise for today.